Hi, this is Roopa Prasad, Department of Computer Applications, MITS College. So today in the series of data structures and algorithms, we are going to discuss about the topic called as linked list. First, we see the contents of the linked list. So in this one, we are going to discuss about the introduction part of linked list. Then we go for how the linked list can be represented in memory. Then we talk about advantages as well as the disadvantages of linked list. Then we go for the operations that could be performed on linked list. Then we discuss about the types of linked list. In the types, especially we discuss about the single linked list. So in this one, we are going to discuss about the 4 algorithms, that is for inserting a node, deleting a node, searching a node, and display the all nodes. So coming to this introduction of this linked list. So what do you mean by linked list? Linked list is nothing but it is sequential representation of data. Okay, so what we are saying is a linear collection of specifically designed data elements called nodes linked to one another by means of pointers. Actually, in order to store, it is one type of data structure. So that means the way of organizing the data in the memory. So we are having an arrays data structure. So arrays, what you are going to do means we are going to store the data in the sequential order. But there is a limitation for the array. That is what, if the memory is not, the list has to be allocated in series, in a sequential order. If the sufficient memory is not available, then we cannot able to store the data. But in the case of link, what is the advantage of linked list over arrays means, wherever we have the memory, there we can store the data and that can be linked. Okay, even it appears as a linear sequential linear list. So here, this we call it as a node. Okay, this way of calling it as a node. And this node is divided into 2 parts. One, in the first part, we are going to store the data. And in the second part, we are going to store the address. That is the address of the next node that you want to link. Okay, so that we call it as a node. By using the node concept, we are going to create the list. So whenever the memory is available, we are going to create a node. And then the link can be provided in order to have the sequential access, sequential storage. So here what we say, each node is divided into 2 parts. So the first part contains the data, that is the information, and the second part is called as an address. It contains the address. So this part we are calling it as a next node. This part we are calling it as a next field. So actually this is the data. So sorry, this is a node. Here the node is having 2 parts. One is called as a data part and second one is called as a next part. In the data part, we are going to store the data, and in the next part, we are going to store the address. So this is a starting node. So we are going to store the address as null. That means what? There is no other element in the list. Suppose if we want to enter another element, then we have to enter the element and we have to give the address of, for suppose this is the first node that we will discuss in detail. Just for example, this is the first node, and again we have created another node. Okay, so here in this next part, what we are going to do means we are going to store the address of this particular node. Like that, the link can be established. So this is a node, and the node is divided into 2 parts. One we call it as a data part, and next one is called as a next part. So in the data part, we are going to store the data element, and the next part we are going to store the address of the next node. And see, now we see how it is represented in memory. So actually this is a memory locations. So see that the memory location is 1 7. This is a start node. This is a start node. So this node contains the address. That means what? It contains the address of this particular location. So a link is established between this node and this node. Here we are going to store the data. So see here in this node, what is the address? 10 is the address. 10 is the allocation of this particular node. Like that, we are going to make the chain. We are going to link one node to the another node. Finally, the last node will be null. Okay, the next field of the last node will be null. That means there are no more elements in the list. That's what how it is represented in the memory. So see here, the next pointer of the last node contains a special value called as a null pointer. Null pointer means it is the last node, and start pointer will hold the address of the first node in the list. If start equal to null, then it means there will be no list. Okay, obviously we can say if it does not contain any address, it contains the value null, that means what? There will be no elements in the list. That is a empty list. And coming to the advantages as well as the disadvantages, linked list has advantages as well as disadvantages. So what we say under the advantages part, we can say that linked list is a dynamic data structure. Dynamic means runtime it can grow and shrink. Just to compare to arrays. Arrays are static. So for example, if we are declaring the array as a size 10, then in that particular array, we can able to store 10 elements only. Okay, suppose if we have 11 elements also, we cannot able to accommodate in the array. But in the form, in the linked list, what happens? The linked list can grow or shrink during the execution of the program. We can able to increase the size of the linked list, or we can able to decrease the size of the linked list. So that we call it as a dynamic data structure. Because of having the dynamic data structure, linked list has having the advantage. Okay, our next advantage what we are going to discuss is efficient memory utilization. So here we can utilize the memory efficiently. That means what? Instead of wasting the memory, we can go for the dynamic representation. That means if we go for an array, then what happens? Suppose if you are declare the array as a of 10, that is a is an array, and if you declare as 10, then what happens? 10 memory locations has been allocated for the array. Even though if we are having 5 elements in the list, the remaining 5 will be wasted. Okay, so what we are going to do means here we can with the linked list we have a efficient memory utilization. That means the memory is not pre-allocated. So memory is allocated whenever it is required. So as of you are going to enter the data elements in the list, the array size can be increased, and we can store the data anywhere in the memory wherever you found the memory, available memory. That is one of the advantage. And another advantage of linked list is insertion deletion is easier. Okay, we can able to insert any element at any place, and we can able to delete any element at any place. So it is having the flexibility. It provides a flexibility to insert or delete the element at any specified location. And coming to this linked list, we can carry out many complex applications. So these are the some of the advantages of linked list. Whereas coming to the disadvantages, we require more memory. Why? Because so in the node, as we have seen, in the node we have two elements are there, two parts are there. The first part we are going to store the data element, and the second part we are going to store the address. So for storing the address, our memory location will be, we have to allocate the memory location in order to store the address. So that is more memory is required to store a single element also. Okay, for example, if you want to store a single element 12, then also we have to allocate the memory in order to store the address pointer as null. So that is one of the disadvantage of the linked list. And coming to this, access to the data element is time consuming. That means what? Suppose here how the data will be allocated means wherever the space is available, there only we are going to allocate the data. Suppose if you want to access the data, if you want to access the third element in the list, then we have to go through traverse the chain. That means what? First we have to go for the first node. Then using the address of the first node, we have to go to the second node, and using the address containing the second node, we have to go to the third node. So it is a time consuming process. Whereas coming to an array, directly we can able to access a third element. That is one of the disadvantage of this linked list. And coming to the operations that can be performed on linked list. So we have a primitive operations like we can able to create, can able to insert, we can able to delete, we can able to traverse, and we can able to search, and we can able to concatenate. So these are the basic operations that could be performed on linked list. That is a creation operation, insertion operation, deletion operation, traversing operation, searching operation, as well as a concatenation operation. Creation means creating the list. Insertion means inserting the data elements in the list. Deleting means deleting the elements in the list. Traversing means moving through the list. That is moving, bypassing over the list. And searching means searching a particular data item. Concatenation means two linked lists can be concatenated and made as a one list. So these are the primitive operations that could be performed on linked lists. Then we talk about one by one. So what is the first operation? Creation operation. So this creation operation is used to create the linked list. So once a linked list is created with one node, insertion operation can be used to add more elements to the node. Okay, that is a basic thing. First we have to create a node. After that we can have the list by inserting the data elements. So this is the start node which contains the address of the first node. So this start does not contain data, it contains the address only, and it contains the address of the first element in the list. This is a pointer. So and this next field of this first node contains the address of the next node if there is an address. So first is a creation operation which is used to create the linked list. And next, coming to the next operation, that we call it as insertion operation. By the name itself we can say insertion means inserting a new node, so the node can be inserted in the specified location. That means we can able to add at the beginning of the linked list, or we can able to add at the end of the linked list, or we can able to insert a data element in between the linked list at the specified location. See here in this diagram we can explain. And suppose we have a one element in the list that we have created, that is the 30. This is one node we have created. Now you want to insert another element, so we are inserting at the end. So what we are going to do, first we are going to create this node. Then what is going to happen at first, this node, this part, that is the next part of the first node, contains null value. That means there is no element in the list. Now we have created another node with the element 40, and this address of this particular node will be allocated in the next field of the previous node. Like that we are going to create a list. Okay, that is inserting a node at the end. Okay, and we can insert the node at the beginning also. Suppose we have 30, 40, both elements are there. Now we have to insert an element 10 before 30. Then what we are going to do? We are going to create a one node with the data element 10. And what you are going to do means the start pointer. What the start pointer contains? The start pointer contains the address of this particular node. Okay. So what you are going to do means the start pointer, we are going to change, what we are going to do means here this node has an address. So this address will be allocated in the start pointer, and address of this node, that is the 30th element node, is will be stored in the this node address. Okay, like that we can able to add the element of the beginning of the list, and we can able to add at the specified location also. Suppose if you want to insert an element at the second position, so what you are going to do, first of all, this node contains the address of this node. Okay, now what you are going to do, you are going to create one node. Okay, and this address will be located in this particular node, and here we are going to store the address of this particular node. Like that we can create we can able to insert the node at any given position, second position, third position, whatever may be the position, you can able to insert. So insertion can be done at the beginning, insertion can be done at the end, and insertion can be done at the specified location. First of all, you have to create the node. After that, you can able to perform the insertion operation. Then coming to the deletion operation, here also same. Deleting the node means we are going to remove the node from the linked list. We are going to free up the memory. So we can able to delete the node at the beginning, or we can able to delete the node at the end, or we can able to delete the node at the specified location. Suppose if you want to delete the first node, okay, if you want to delete the first node, what you have to do means the start pointer contains the address of this particular node, right? The start pointer contains the address of this particular node. Then what you are going to do means instead of this address, we are going to store this address. That means what? The node will be detached from the link. The node will be detached from the link. As soon as the node is detached, the memory will be deallocated. Okay, is it clear? So we are having this 20. This node is having some address, and this node is having some address. So what you are going to do? If you want to delete this particular node, in the start pointer, instead of this address, we are going to store the address that is present in the next pointer, so that this node will be removed and this will be the starting node. Okay, like that we can able to delete a node at the beginning. Then coming to the end of the node, what you have to make means, so in this node contains the address of this node, right? This node contains the address of this node. So what you are going to do means, you are going to make this address part as null. That means what? We are going to remove the address of the next node, so that the node will be deleted, removed from the list. As soon as the node is removed, it will be deleted. It is called as deleted. Now what we can do means, we can able to specify location also. We can able to remove at the specified location also. Suppose if you want to delete this 20, okay, this element, that is the second element you want to delete. So obviously what we have in the first node address part, we are going to have the address of the second node. Okay, and in the second node address part, we are going to have the address of the third node. So what you are going to do means, what can be done means, so here instead of this address, we are going to store this address. Okay, so this node will be deleted automatically. This node will be deleted. Here, what is the concept? Here it contains in this address part, in this next part, it contains the address of the next node. So instead of storing this address, we are going to store this address. That means what? This node will be detached. Like that, we can able to delete at any specified location. And next, coming to the next operation, that is traversing. So what do you mean by traversing? Traversing means it is a process of going through all the nodes from one end to another end of the linked list. For searching process, for deleting, or for inserting process at a specified location, we need the operation called as a traversing. That is moving from one node to the another. Okay, by passing the chain. Suppose this is a start node. Okay, start node contains one address. So that address is this one. This node contains, and the address part of this node, it contains the address of this node. So we have moved to the next node. And in this node, the address part contains an address of the next node. Then we have moved to this node. Like that, we have to move from one node to the another node, from starting position to ending position. That we call it as a traversing. So as we have seen that traversing is required in the insertion process, deletion process, anywhere. So suppose if you want to insert at a specified location, suppose if you want to insert at the third location, we have to traverse the first node and the second node also. Okay, if you want to delete the fourth element, then you have to traverse the first element, second node, and also the third node in order to delete. So traversing is required for the insertion operation, searching operation, deletion operation. Anywhere traversing is required. Okay, why this traversing means, we are not having the contiguous memory allocation. So the wherever the memory is located, there we are going to store the node, and we are providing the link. That we call it as a linked list. So here we can visit from left to right, forward traversing only, but we cannot have the backward traversing. Suppose you are at this node, we cannot come back to the previous node. Okay, why? Because this node contains the address of the next node only, but it does not contain the address of the previous node. We cannot go for the backward traversing. Only forward traversing is allowed in the singly linked list. So in order to have the backward traversing also, there is another linked list, another type of linked list, that we call it as a AA linked list. There we can have the forward traversing as well as the backward traversing. And next, coming to the next operation, that is a concatenation operation. So in this concatenation operation, concatenation means what? Appending. That is adding to the second list to the end of the first list. Suppose a list is having n nodes. A is a list and B is a list. A is having n nodes and B is having m nodes. Then we can able to add. Okay, so n plus m. Okay, like that we can able to concatenate. Concatenation operation is also possible in the linked list. Okay, so coming to the types of linked list, as we have already said, we have three types of linked list are there. Singly linked list, doubly linked list, and circular linked list. Based on the address part. Based on the address part. Singly linked list. By the name itself, we can say singly linked list. Linked list is having a forward direction only. There is only one list part. There is only one next part where we can store the address of the next list. Okay, doubly linked list means this node is having the list for the previous node as well as the next node. Circular linked list means what? At the end of the list contains the starting address of the list. That we call it as a circular linked list. And in this presentation, we mainly focus on the singly linked list. Okay, coming to the operation single linked list. So here in single linked list, all the nodes are arranged in sequentially. All the nodes are arranged sequentially by linking with a pointer. By linking with a pointer. Okay, and this single linked list can grow or shrink because of its dynamic structure, and all the primitive operation, that is creation, insertion, deletion, traversing, searching, and concatenation, can be done on the singly linked list. And coming to the operations, so we can able to perform the insertion, we can able to perform the deletion, we can able to perform the traversing, and we can able to concatenate. So we discuss some of the algorithms. So this is the algorithm for inserting a node. So we can insert a node at the beginning, at the end, as well as at the specified location. So first we discuss the algorithm that is inserting a node at the beginning. So what you have to do means, this is the algorithm. So for what is the first is, you have to input the data to be inserted. Okay, whatever the data you have to insert in a list, that data you have to read from the user. Then you have to create a new node. You have to create a new node. This is a new node. Okay, so as we have already discussed, the node is having two parts. One we call it as a data part, and one we call it as a link part. Simply we can say the data part and the link part. So new node of data. This is a new node. The name of the node is new node. New node of data equal to data. So whatever the data we have taken from the user, that will be inserted in the data part. That will be inserted in the data part. Okay. Then we are going to check whether this node is a starting node or it is the next node. So what you are going to do, if start is equal to null, start contains a pointer. So start equal to null. If it is a null, then what you are going to do, new node of link equal to null. We are going to make the new node of the link equal to 1. That is, we are going to insert the node at the beginning. Okay. So if start equal to null, then new node of link equal to null, else new node of link equal to start. So we are going to store. For example, this is a node. Okay. So here what you are going to do, new node of link, this part will contain the address of this part. So we are assigning the start address to the new node of link so that it becomes the first node in the list. First node in the list. That is the algorithm for inserting a node. Once again, we'll tell. First, you have to input the data to be inserted. Then you have to create a new node. Then that data has to be inserted in the data part of the new node. Then we have to check the condition if start is equal to null. Okay, if it is equal to null, then what you have to do, there is no list in the, no elements in the list. We have to make that as a first element. So new node of link equal to null. Okay, then else if it is not, start is not equal to null, if it is having some elements, then what you have to do, you have to insert at the beginning. So what you are going to do, new node of link, this one is equal to start. Here we are going to here we are going to store the start address. Then start becomes a new node. New node becomes a start. New node becomes a start. Okay, that is the algorithm for inserting a node at the beginning. Then coming to inserting a node at the end, simple one. Okay, so what you are going to do, you are going to create a node, then you are going to insert the data element. Then what you are going to do means, you have to make this link as null. Okay, there is no need, you have to make this node as null. Why? Because means this will be the last node. This will be the last node. So we have to make the next part, link part of this new node as null. Okay, if start is equal to null, then you have to make the new node as a start. Okay, that is inserting a node at the end. Coming to inserting a node at the specified location, then you have to read the position also, where you have to store the data, where you have to store the data. Okay, where you have to store the node. Okay, so you are reading the data and you are reading the position also. Then you are going to take a temporary variable called as a temp, and we are going to allocate this start as temp. We are naming this start as temp, and we are going to, for iteration purpose, you are going to take the k value. Then what you are going to do means, repeat step 3 while k is less than POS, that is a position. So until if the position is equal to 2, then you have to traverse the two elements, right? So at the second position, you have to insert means you have to traverse the two elements. For that purpose only, we are going to take the k. Then what you are going to do means temp equal to temp of, you have to move the start. You have to move the start temp. That is a location you have to move. First, you are at this location. Then what you are going to do? You are going to make the temp as this one. This is treated as temp, right? Okay. Then this is a temp. Okay. Then temp equal temp of next. What the temp of next contains the address of this node. So temp automatically comes here. Like that, we have to move until we are getting the specified location. For example, this is a specified location. Then what you have to do? Now, simply what we can do means you can able to, you are going to traverse here. So you are going to make the temp of link equal to temp of link, and you are going to increment k. Okay, so see here. So you are going to create a node. Then new node equal to a new node of data equal to data. New node of next equal to temp of next. So this is a temp. This is a temp. Okay. So what we are going to, this is a new node. New node of link. New node of link equal to temp of link. What is temp of link? This is temp, right? So temp data, temp link. So what the temp link contains? The address of this node. So what you are going to do means new node of link equal to temp of next. Like that we are going to link. Like that we are going to link in the in between. That the specified location we can insert a node. That is the process of inserting a node at the specified location. Then coming to deletion part, simple, same as it is. So now we have shown this one. So for example, if start equal to data so we have to give the data that has to be deleted. Either it can be first element or last element or it in the middle. So what you are going to do, you are going to check whether the start of data, this is a start of data is equal to data. Okay, start of data is equal to data. If it is not equal, then what you are going to do, you are if it is equal to data. Okay, suppose if you want to delete 20 and it is equal to 20 only, then what you are going to make, you are making this as temp. Okay, then what you are going to do, start equal to start of next. So we are going for the next one. This is a temp and this is a start only. So start equal to start of next. So this becomes a start and we are going to delete the node. Whatever the node that is a temp, we are going to delete. Set free the node temp. Okay, like that we can able to delete a node. Okay, and suppose if you want to go for the last node, then you have to go for the last node. You have to traverse to the end of the node. For that purpose, we are going to take another variable called as a hold. Okay, so this is for the traversing purpose. While hold of next next of next is not equal to null. Okay, hold of next, this one, suppose this one is hold of next, of next, and means this one is not equal to null vargu. Null, until that we have to move. I will have to move. So what you are going to do means you are going to set up the temp. So for that purpose, you are going to take the hold and we are going to take the temp also. Like that we can able to delete until the traversing. Suppose if the hold of next equal to null, that means what, at the time traversing we reach this particular node, then what you have to do means you have to that means the data which you want to delete is not found, then we are going to display the display one message called as data not found. And then coming to searching a particular node. So for this particular node searching, what we can do, simply here also we have to do traversing. So first we are going to input the data to be searched. Then we are going to initialize temp equal to start and position equal to 1. First, from the first position you are moving. So repeat 4, 5, 6 until the temp is equal to null. Until it reaches to last node, we have to search. Okay. So first, what is the first option we are going to check? Temp of data is equal to data. If temp, for example, this is a temp. We have initialized temp to start. Start means it contains the address. So this is a temp. So we are checking if temp of data is equal to whatever the data we have given. For example, if you want to search 32, so what happens? Temp of data is 30, and what you have to search? You have to search 32. So it is not equal. So what you are going to do? You are going to skip this one and you are going to come this one. That means you are going for the next node. So temp equal to temp of next. No, now the temp is this one. So what we are saying, temp equal to temp of next. So what is temp of next? This one. So temp becomes this one. Temp becomes this one. Again we are going to increment position. Position becomes 2. That is the second node. Again we are coming for this one. Temp of data is equal to data. What is temp of data? 31. And what is the data? 32. It is not equal. So what you are going to do? You are going to move. You are going to make temp equal to temp of next. That means you are making the temp as this one. Temp of next is this one. Temp equal to temp of next means the temp becomes this one. So again we are going to check the increment the position, that is position equal to 2. Then you are going for this one, that is the fourth one. If temp of data is equal to data, what is temp of data? 32. And you are going to search for 32. That means it is found. If it is found, then we display the message the data is found at position. So what is the position? Position equal to 2. So what the message it will be displayed? It will display the message the data is found at position 2. Okay. If it does not work, then what happens? If temp is equal to null, so it is not found here also, then temp becomes this one. And here also the data is not matching, then the temp becomes this one. Now ultimately what we can check, if temp is equal to null, temp is equal to null, then what you are going to display? The data is not found in the list. That is the algorithm for searching a node. Okay. So searching also we have to traverse. We have to traverse each and every node. So and this is the algorithm for displaying the all nodes. So if start is equal to null, start is equal to null. If it does not contain any address, that means what? There is no list. Okay. If start contains address, that means it contains a node. Okay. So what you are going to display? The display we are going to display the list is empty. Then what you are going to do? Initialize temp equal to start. That is whatever the address in the start, that will be initialized to temp. So for example, the start contains that address. So temp is this node. Temp is this node. Next, what we are going to do? Repeat 4 and 5 until temp is equal to null. So display temp of data. We are going to display the temp of data, and we are moving for the next node. How we are going to move? Temp equal to temp of next. First of all, temp is this one. You are going to display the data 30. Then what you are going to make means you are going to make the temp as temp of next. So what is temp of next? The address of this node. So temp becomes this node. Like that we have to move until temp is equal to null. Temp is equal to null. Up to that we have to move. We have to traverse from each and every node. In between we are going to display the element temp of data. Okay. So these are some of the algorithms in the linked list, and this material is prepared by using this textbook. And if you have any queries, you can give your question to this form. Hope you understand. Thank you.